Hey everyone, and welcome to Superhack workshop titled Tokenized Vault Standards. Joining us today is Vikram, who will be taking us through this session. And with that, I'll pass it over to Vikram to get the workshop started. Over to you, Vikram.
Thanks, Calvin. Yeah, excited to do this with you guys. Lots of interesting developments in DeFi over the last few years, and I think tokenized vaults are one of the cooler things there. So excited to talk about that with you guys. And yeah, any point during this, it's meant to be interactive workshop. So feel free to just drop questions in the chat, and I'll be reading it. Try to read it, and we'll see how it goes. Okay, cool. Let me share. So I have a deck that I put together. This will be maybe more on the technical side, but hopefully it's helpful for people who have been really getting into it. Let me make sure this is shared properly. Okay, can you guys see just the screen, just the slides?
Yeah, we're good. I can see everything.
Okay, great. So yeah, I'm Vikram. I'm one of the co-founders of Superform, and I've been contributing at the ERC 4626 Alliance. And recently, we've had a lot of tokenized vault standards that have been approved, and just kind of wanted to talk to you guys about those, and what they are and how to actually build on top of them, and some useful tips that we've gained from my experiences at Superform and just generally with working with protocols in the DeFi space. So yeah, what we'll talk about in this workshop is, first off, you guys have probably heard the name tokenized vaults 100 times now. First we'll cover what those actually refer to. And then we'll talk about two of the most popular tokenized vaults out there right now, 4626, and then one which was approved last month called 7540. And then we'll run into some development tips and considerations, and then we'll open it up for Q&A. But as I said, feel free to drop things in the chat, and I'll try and take a look if there are any questions that come up in the meantime. All right. So if we think back to what DeFi is trying to do, it's really allowing people to make the money efficient. I can use smart contracts to be able to put money in and get money out. And before, blockchains would really only be able to be used for actually storing and moving value. But with DeFi, whenever DeFi came around a few years ago, we pretty much said that's actually storing and moving it is only one tiny bit of what money is. Let's figure out how we can make money permissionlessly. And that idea of putting money into something, having it make money, and then returning more money out is pretty much what these tokenized vaults are trying to tackle. Is we're trying to standardize this arbitrary money-making logic, and in doing so, I think it's solving some of the biggest issues that DeFi faces right now in scaling, which is that DeFi generally has a lot of ways to improve on the security side. For the amount of TVL it has, for sure, we can be doing a better job there, and increasing composability. And also, once we solve those first two things, that makes it a lot easier for us to safely and be fast with how we're innovating. So that's kind of why it's important. But a little bit more on exactly where tokenized vaults fit into this is it pretty much standardizes that arbitrary money-making logic into a tokenized vault. And I'm actually not sure if I start moving my cursor around. Can you guys see that on the screen?
Yeah, I confirm. Yeah, we can see that.
Yeah. So yeah, tokenized vaults, there's really two flavors of them. One is a synchronous vault, and one's an asynchronous vault. Synchronous vaults is ERC 4626, and there's now over $9 billion of TVL in it. We have yield aggregators, lenders, automated strategies now that are built on top of 4626. Very basically, how a tokenized vault would work is that money comes into the vault through deposit or mint, and then it leaves the vault through redeem or withdraw. And these are totally synchronous actions. Users would be able to transfer assets to get shares, and then shares to get assets. All that stuff is, you can see all that stuff happen on chain. Now, ERC 4626 is particularly relevant for your typical DeFi vault, right? Things that can exist totally on chain. But as we, as DeFi grows up and it matures, and we're trying to bring a bunch of assets that have never been able to be on chain, we have to be able to provide some sort of asynchronous support, so that, I actually might need to do KYC before I can enter a vault, or maybe the asset that I'm investing in is in the real world, and to actually get my money out, I have to like go to a custodian and then like go to a bank, and then like it gets transferred on chain, and there's a whole process right around how I actually like would get my money back. So 7540 pretty much takes what 4626 built, that core infrastructure, and it just adds this request lifecycle on top, where pretty much to get money into a vault, you first have to request a deposit, and then once your request is approved, then your money goes into the vault, and then to get money out, you have to request a redemption, and then the vault will fulfill it, and then you'll get money back. So very basically, these are like the two things that are going to serve the backbone of like any sort of tokenized vault strategy, or anything in DeFi really can be put on either of these two standards at this point. And there are a couple other like supplementary things that we'll talk about later that help, but these are really the two building blocks that we have for being able to support all kinds of yield on chain. So we'll talk a little bit about ERC 4626 first, and then we'll jump into like the new stuff on 7540. But just to like cover the bare bones of how vaults generally work, is, I mentioned this before, but money comes in through deposit mint, leaves through redeem withdraw. We'll talk about how money comes into vaults, and then we'll talk about how money leaves vaults, and then just like some other important functions that you should know are present in the standard. So getting money into vaults always starts with the underlying asset that the vault accepts. So you can think of that, that's just, whatever, USDC, DAI. If you want to use a native asset, you can also use that, but we'll take a look at, there's another standard 7535, which does that. But an asset can be anything really. And there's two ways that you can get money in. The first is a market order, which is just normal deposit. So I'm pretty much coming up to the vault and I'm saying, hey, I have 100 USDC and I'm looking to get however many assets, however many shares that you can possibly get me, market order. And then there's a condition here where I want to make sure that the amount of assets that I'm depositing, it can't be greater than what the vault is set to be the max deposit. Vaults will want to implement max deposit for multiple reasons. Maybe there's a vault cap, whatever else. They want to make sure that, their yields don't get diluted, whatever. So vaults can implement max deposit on a per user level, actually. So like they could implement that, hey, every user can only deposit 100,000 USDC or whatever. Preview deposit is something that's used to figure out how many shares should be received for assets that are being deposited. So these two conditions, first, the amount of assets that you're depositing has to be less than max deposit, and the amount of shares that you're going to get back should be the bare minimum of shares that you've actually received. So this is really just like the preview deposit is a lower bound, so the users know, front ends know everything, what the execution expectation is for a given action. And then assuming that condition passes, then we have effectively swapped assets for shares, and then we emit the deposit event. On the flip side, we have another way to get shares, which is a limit order, where we just say, hey, I have this USDC in my wallet, but I just want to get 100 shares. Now, how many assets do I need to actually do that? So really, like this is like a fixed order. This is variable, and the two conditions here are, I want to make sure that the amount of shares that I'm asking for is lower than what than the maximum amount that the user is allowed to mint. And then similarly to the preview deposit and share check, we have an asset check compared to preview mint, where I just want to make sure that the amount of assets that I'm minting for, that the amount of assets taken out of my wallet is less than what was indicated through preview mint. So it's just like the lower bound for user security. And after that's successful, then we emit the deposit event similarly. I guess a couple notes. Assets should just be one ERC20 token. I mentioned in the very beginning, like if you want to use native assets, check out 7535. If you want to use multiple assets for an underlying, check out 7575. And that's how you'd be able to support, like double-sided LP or whatever, if you wanted to have different different ways to get into a vault. Some other things, if a vault can't be deposited into, that's where we use the max and preview functions. So max functions should be on a per user level, and then preview deposit is on a broad, anybody should be able to call preview functions and then see how many assets I'm going to get. And yeah, whenever we deposit, it should return exactly what the return type is, the return amount back to the receiver, whoever was asking for shares. And some rounding things here and everything, like we've encountered some of like the ST vaults and stuff, which on Lido, just like, be careful of like some rounding things on that, and you'll be golden. So that's getting money into vaults. Getting money out of vaults is really very similar, but we replace deposit with redeem, which is the market order here, and then withdraw, which is limit order. A little bit confusing, I know, because you typically think of deposit and withdraw being antonyms, but in 4626 case, it's redeem. So pretty much the same conditions apply. Shares, we're asking that it has to be less than the max. Preview redeem, again, is used as a lower bound, again, so that users don't feel like they got rugged when withdrawing from a vault, because preview functions should tell them like the least amount of assets they should receive, so they have an idea. And then same on withdraw, really, except we use the preview and max withdraw instead of redeem. Some edge cases here to keep in mind is many vaults have implemented like time lock behavior. Even DeFi ones, right? It's like, I don't know, maybe it's a tranche product, or there's like some collateral thing and you have to like call it back or whatever, and you have to like cool it down. Like Athena is actually a great example of this. Athena has totally synchronous deposit steps, but then on withdrawals they have it so that there's a cooldown period and you have to like request a cooldown of shares. If you do that, we'll talk more about 7540 and how that can be used natively, but in the context of 4626, if a user is time locked, then the correct behavior, which all these vaults have implemented, is to just have your max functions and preview functions return 0. And yeah, that's pretty much it for like the core flow of how 4626 works. Some other functions, it inherits stuff from ERC20. So like every 4626 is also an ERC20, and then we have a bunch of functions in 4626 to do your typical like math calculations. We have total assets, convert shares. Pretty much you can get TVL and APY and everything directly from those. Just be careful in like using these things on chain. I would be just like a little bit wary on, because some of these numbers could definitely be spoofed. And for the focus of like how do we display APY on and like vault details, would generally gravitate toward using total assets and total supply rather than the convert functions. But that's a nuance, and for hackers listening to this, you're probably focused on the protocol, so that's probably good here. Yeah, I mean, just general recap: preview functions or simulations, max functions, constraints, convert functions or pricing. Generally, just remember that. And there's no slippage parameters in core functions, so generally in depositing to 4626 vault, we recommend going through a router, but that's separate from the actual like security concerns that a vault would need to address per se. Yeah. All right. Now for some new stuff here, we'll talk about 7540, which is again proved a few weeks ago, and there's not too much stuff out there outside of the spec, so hope that this can be a good resource. And yeah, generally the reason why we built 7540 was because there are a lot of vaults on 4626 that we had to introduce some sort of asynchronous capability to actually be able to bring more types of yield on chain. And that happens by essentially creating a request cycle for each action, for each deposit, each redemption. And we'll have a note here is that 7540, you don't have to implement both request deposit and request redeem. You could just implement one or the other. And we have EIP 165 support so that you can actually like indicate, is it just asynchronous this way? Is it just asynchronous on redeem? We were expecting like, most vaults would probably just implement the request redeem section. But request deposit could be important too for lots of assets that you don't maybe it's capped or whatever, and you don't necessarily know whenever you're submitting assets on chain. And then just a note here is that 7540, there's something called request IDs. We're just going to be covering request ID of 0 cases. And for anyone hacking on 7540 for this, I'd recommend like just focusing on the request ID scenarios, because not equals 0 is, there are just some things there that honestly the spec would need to write another spec for properly handling that. And there's just other things to consider there that probably would be, could be a rabbit hole to go down. So. All right, talking about the general request cycle, pretty much the TLDR is that we have vaults that cycle from pending to claimable to claimed. And to go from each one of those steps, there's some action that either the vault or the user has to take. So it starts with the user. So the user would request a deposit. On the request deposit step, assets are already sent to the vault. And once assets are sent to the vault, we increment your pending deposit request so that the vault's pending. And then when the vault's in pending, the vault operator at any time, imagine this is BlackRock, right? Like something in their logic, so that they've been able to actually, deposit your assets into the opportunity. They passed all of like your KYC checks, whatever. That internal fulfillment would then be pushed on chain. And then your pending deposit request would go down. That was increased here. And then your claimable deposit request would increase. And then a vault goes fully into the claimable step. Whenever a vault's claimable, the thing that the user would need to do is then actually deposit that claimable deposit request into the vault. And that deposit step looks like 4626. We could go back to like the deposit thing, and the same stuff applies for the most part. But there is a side note here, which is that 7540 requires that you overload the deposit function with this added address controller variable. This is needed because, again, this entire thing is like a two-step process, right? Because the user requests a deposit, vaults are in pending, and then it could take an arbitrary amount of time for the vault operator to actually fulfill this. It could be dependent on all kinds of things. So in that process, to make it easier on the user, instead of having the user just sit there, monitor this thing, like refresh their page for weeks, you can delegate and authorize a controller. This could be another protocol, it could be an integrator, and that integrator can then control your request so that it makes it way easier for the user to actually manage that. And to properly support that added UX benefit, we have to overload the deposit function to allow for this address controller to make that deposit, not just the user or the receiver. And yeah, so after the user or the operator will make this deposit, assets are moved. They're already in the vault, but they're deposited, and then your claimable deposit is zeroed out, or to whatever degree those assets were deposited, and then shares are sent back to the user. And yeah, the general flow here is, we will emit the same events in 4626. We have request deposit events that are emitted on this request deposit step. And I guess the big difference compared to 4626 is that the assets are sent on the request deposit step as compared to on the deposit step, because the vault operator needs to be able to, at any time, pretty much move the assets into the vault. And yeah, notes here, I think already covered this. So yeah. Really same thing for the request cycle on redemptions. The only thing here is that there's no overloaded function required, because redeem in 4626 already supports the additional parameter. And yeah, that's pretty much for that. Just some notes on 7540 generally. You guys probably noticed that only request deposit and redeem and request redeem are supported, whereas in 4626 both mint and Majara here. The reason why, excuse me, only those are supported is because mint and withdraw, remember those go off of like the output asset. And in 7540, it's a little bit misleading to make it to request a deposit asking for shares when you have no idea exactly like how many shares the operator would be able to give you. And, imagine it takes them like 3 weeks to fulfill it. It's just way cleaner to just go off of the input asset rather than the output asset. And because of because of that fact, in 7540, preview functions must always revert. So all those things that we talked about in 4626, the redeem, all of that, those should revert because there's really no way for us to create a condition on which execution should be reverted. So we just say preview functions revert them because that shouldn't be included in execution logic. So you might ask, okay, how do we actually figure out then? How do we show users how many shares or assets they're going to be getting? That's convert functions are still present in 7540, and that's what you can use. Two side notes on other ERC support is that we mandate ERC 165 so that integrators can tell if either request deposit or request redeem are implemented. And in any case, let's say that a vault didn't implement request deposit, then it's assumed that that step is 4626 synchronous for integrators, and 165 just helps us figure out where exactly and how that flow should work. And yeah, same thing with 7575 on the asset. So we can support multiple assets through 7575, and that's part of the spec. Some security considerations in creating this. Just implicitly in 7540, there's way more trust in the on the vault operator, right? Because pretty much this entire like internal fulfillment step is something that's totally off chain and not standardized. So they can do whatever they want. Like technically, if the vault operator doesn't move it to claimable, assets could be stuck in the vault. You'll notice that like we didn't actually have any cancellations that we included in the spec. Obviously feel free to incorporate cancellations and whatever you write. But the reason why it's not is because there's just asynchronous nature of those. Like sometimes they could be fulfilled and a bunch of edge cases, but definitely something that would be important because it could cause dead assets. And similarly, still no slippage parameters. And keep in mind that exchange rates of shares and assets after request deposit could definitely change. So we don't assume that like the convert functions at the point of request deposit will still exist whenever the vault operator actually makes it claimable. And then, so this redeem step or this deposit step here, it's two-step for a reason. The user controller should be the one who calls deposit or redeem after shares become claimable. If you try and like have some system where that second step isn't incorporated, then all of a sudden it gets really hard to track, and users or protocols, whoever is integrating, like they end up with assets and shares that they don't know how to push back to users. And it's just easier if we have it all standardized around being two-step. And then I already mentioned the request ID equals 0 case, but pretty much on all these request deposits and request redeems, or you can increment request IDs, but far easier to just keep it as 0 and use the controller parameter to distinguish requests. All right. So hopefully you guys have a better idea of what the standards actually are. In terms of building them, there's been a lot of progress on being able to create these better, safer, and the toolkit that we recommend right now to build ERC 4626s is what Yearn's done with their tokenized strategies. So they've particularly built this tokenized strategy repo so that you can just fork it, modify like 3 functions in there, pretty much how funds are deployed, how funds are withdrawn and harvested and reported. And then that's all you have to do. And then you can just simply deploy that rather than like, you guys actually going through all of this crazy stuff and trying to like figure out how all the math works and keeping all that straight. So highly recommend just directly checking out what Yearn's done in their V3, and it's super easy to deploy. And there's already been a bunch of strategies built on their tokenized strategy repo. So I linked a couple, and I think it's in the hackathon thing now. but you can check out the like Compound V3, Ajna, Pendle, Gearbox. They already have all the strategies on there. And these are great resources for you to take a look for any of the Vault implementations that they're trying to build, because this is pretty much exactly what the hackathon is for. And then on the 7540 side, it's far earlier, and the best implementation to take a look at is Centrifuge's 7540. But it's a really good reference, and for the bravehearted that are looking to really be on the cutting edge of what we're doing on vaults, we definitely take a shot. But notably, there's far less resources to do that, but we're happy to answer any questions. Just jump into the 4626 Lines channel, and obviously I'm happy to, I think this is it, right? Yeah. And I'm happy to take any questions now that we're on here. So that's it. Thanks, guys.
Thank you, Vikram, for the great presentation. I believe we have few questions on the chat box. I see one from Aryan. Do you want to take that?
Yeah. What is the question, Aryan? Okay. Can you define? Yeah, that's pretty much it. So this first diagram, right? This arbitrary money making logic is a vault. Whoever I want to move money to a strategy or anything and then get money out of a strategy, that's it. A box is a good way to think of it.
All right. Anyone was any questions for Vikram? Yeah, we got one question from Superono.
Min. Yeah, so it's interesting. No, there's nothing in the specification on a min deposit. But you could, I mean, I guess the benefit of doing it is you could reduce spam to your vault, but I'm not sure if, unless you're incurring like a large cost by processing that. I think in 4626 it'd be rare for someone to implement a min amount, but definitely could see that in 7540. And pretty much like a way that a min amount would be used in 7540 is like, whenever you request a deposit, your request would just be denied if the amount was too small. It'd be interesting. Yeah, and I'm sure there are definitely like a lot of RWAs that would require investment strategies that would be implementing that, but haven't seen that in 4626. Carol asks, any examples of strategies, use cases? Yeah, I think Centrifuge is great, and would definitely take a look at their implementation. But pretty much what Centrifuge is doing is there are funds that exist off chain that they're looking to get access to on chain capital for. So pretty much people will deposit, and then that capital is then moved and invested off chain, and then users can monitor like the fund and the status and everything of that on chain. If you were to look to like just make something in terms of like in a DeFi sense, LSTs and LRTs would be great to tackle on 7540. And honestly, like Athena and Puffer and Ether, right? A lot of those projects, they actually are 4626. And if you guys want to take a look, you go to tvl.erc4626.info. And a good amount of those vaults actually do implement some sort of two-step redemption process, and that could all be on 7540. And it would be really cool for someone to wrap one of those protocols in 7540 to try that out. Niraj asks, expand a little bit more on the controller. Yeah, good question. So pretty much the controller exists to make the process easier for the user. So the user can, I didn't actually include this function, but there's a function 7540 where you can set an operator for a request. So pretty much the user doesn't want to sit around and monitor when this gets to claimable. So they can set a controller address. They can authorize a controller, and this could be a protocol. It could be like manager. It could be like their friend, whoever, really. And that person would then manage the request, and they'd be able to like actually call that later for the user. Yeah, hopefully that answered your question. Same thing exists on redemptions, but it's already 4626. When the vault deposits chain asks, when the vault deposits new lending pool, how does the vault token allow the user? So how it'll know is you can use, assuming this is like 4626, it's a normal lending pool. The way that you could tell is because of the preview functions. It would tell you how much you're getting out. And yet the shares are constantly appreciating with respect to assets. So that number is, all these charts are only up, and that, well, the lending charts for the 4626s are only up. So yeah. Hope that answered your question. Suparno asks another question. Hopefully we have more time to take these. Sorry, I just kept going. Do we have
That's
time?
okay. I think I think we have more 2 minutes, and then we can wrap up.
All right.
Yeah.
So someone invests $5. It's really up to the user. Yeah. So the question is like, again, on the minimum amounts is like, why would a user want to do it? If it's totally up to a user, I think it'd be interesting if there was like some sort of if there are a lot of very small users and deposits into something, you could batch those actions. That's interesting, which is, I guess, what you brought up. But I guess that that'd have to happen. Likely, like I would expect batched actions to happen through some sort of smart wallet, or I'm not sure if that'd happen on a vault level. It'd be some sort of like account level. We absolutely can deposit share tokens as collateral in another vault. And yeah, if you're interested in that, would take a look at the 4626 Alliance GitHub, which I think should be one of the links on the hackathon. And there's actually someone who used 7575 to be able to deposit 4626 collateral natively instead of the ERC20. So definitely check out the 4626 Alliance GitHub and like pull requests there. Okay. Thank you, Chain. Yeah, what type of vaults? So it's whatever you guys want to build. It's really open ocean. That's why we said best vault implementations. I didn't really talk too much about Superform, but pretty much any of these vaults can be instantly listed on Superform, and it's a front end for you guys. So like never, for if you're building a new vault protocol, there's no need for you to actually create your own front end. You can just focus on writing a strategy that makes money, and then you just put it on Superform and you get distribution. And once on Superform, you can actually deposit any asset from any chain too. So we're like the chain abstracted marketplace for this stuff. And if there was something like a cool vault, we already talked about a good amount of things on the 7540 side, like the LSTs, LRTs. On the 4626 side, I think obviously like you guys can use what Jörn's laid out as a framework, and some of the strategies that would be interesting. Like there's a lot of leverage strategies that could be written, and some of the stuff like on Gearbox would be cool. I don't want to like say anything necessarily that would say like there are a lot of cool things that can be built on 4626. So I don't want to like say that just one or two things would be cool, but just we're accepting all submissions, and we're just looking at code quality, how much the strategy returns, but primarily just looking for good ideas, and excited to see what you guys come up with. Cool. Thanks a lot for listening, everybody, and I imagine we're probably at time, so thanks.
Cool. I believe this was one of the most interactive workshops which I've attended. Really good back and forth of questions. So
Yeah.
Cheers,
thank you.
Vikram. Yeah. Big thanks to everyone for joining in, and also thank you, Vikram, for your presentation. Feel free to connect with Vikram in the partner channel on Discord if you have any questions, and I believe they shall get back to you whenever they are free. Cheers, everyone, and have a great rest of the weekend. See you all. Bye bye.